大家好，我是 Gábor, LVGL 的总经理，很高兴参加这次会议。As you can hear, a few months ago I started to learn Chinese. Next time I will tell you a few slides in Chinese, but for now I need to continue in English. So in my presentation, I'd like to introduce LVGL's UI editor to you. But if you are new to LVGL, let's start with a brief introduction about what is it. So LVGL stands for Light and Versatile Graphics Library. So it's a graphics library which helps you to create modern graphical user interfaces for resource-constrained embedded devices. It's a full-featured solution. Usually I say what you can see on an Android or iOS application can be implemented by LVGL as well. It has more than 30 built-in widgets, buttons, charts, sliders, drop-downs, tab view, keyboard, text area, and many others. Its powerful styling system has more than 100 style properties, and it also comes with powerful layout systems like Flexbox or Grid. The same layouts are available on the web pages as well, so if you are familiar with web development, probably you will find these familiar too. It also has events, animations, scrolling, and all the things that you might need to develop fancy UIs. It's a portable and scalable solution. Originally it was designed for small microcontrollers having only like 100 MHz of clock speed and having only a few hundred kilobytes of RAM and flash, but due to the recent updates it runs effectively on NPUs as well. We have a lot of Linux display drivers like Wayland, DRM or the frame buffer device, and we are also working on OpenGL support. LVGL is a popular and trusted solution right now. It's downloaded in every 30 seconds from GitHub and is already supported by the leading chip vendors, the RTOS projects just like RTthread, and also it's being used by the biggest OEMs in smartwatch, home automation, IoT, medical, industrial, musical, and a wide variety of application areas. And I left the best part to the end. It's a free and open source solution. The source code is fully available on GitHub and it has an MIT license. The MIT license means you can use it for free even in commercial projects. All you need to do is just give an attribution to LVGL. So in your documentation or user guide, you just need to copy our one paragraph license to show the word that you have used LVGL. LVGL also works seamlessly in the RTthread ecosystem. Of course, it's available in RTthread's software package manager. You can just pick it from the list and add it to your projects with a few clicks. It also supports many development boards, so if you are looking for ready-to-use projects, chances are high that you can easily find a development board on which you can try out LVGL and create some HMI applications. There is a very interesting thing. At RTthread, there is an LVGL special interest group. So if you have any questions related to RTthread and LVGL, you can just write some experts on WeChat to get help and support. It's very unique. And now we have arrived to the main topic of my presentation, which is LVGL's UI editor. If you are following LVGL's journey for a longer time, maybe you have also heard about SquareLine Studio. I was part of the SquareLine team and I also worked on SquareLine a few years ago. However, last January, so more than a year ago, we have decided to end our collaboration. After that, I felt the need that we need to create an official UI editor solution for LVGL. So we concluded a lot of interviews. We were thinking a lot about how to approach this UI editor topic, how to create something which brings you the highest value. And we have decided to create something which might be different from what might you expect. So it's not a typical drag and drop tool, but it's an XML-based editor. It's more like creating a web page. As you edit and type your XML tags, you will immediately see the result. And there are a lot of tools to make UI implementation for embedded systems easier. We have a Figma plugin. It means if your designers created something in Figma, we make it simple to re-implement that design inside this UI editor. We have an online preview. It means if you push your XMLs to GitHub, a CI action can convert those into a web page, and that web page can be hosted on GitHub pages or basically anywhere, and you can just share a link with your designer team or with your customer so that they immediately see what you have developed. They can try out all your components and screens. Right now we are also working on a built-in test framework. It will allow you to easily test the functionality of your UIs. You can click on some places and click a button to play those tests. Obviously these tests can run in your CI pipeline as well. And we also have a CLI tool which allows you to integrate all this XML validation, code export, test running into your CLI workflows with great flexibility. The current version is version 0.2.2, but we are having weekly releases to keep you updated with all the updates that we are adding. And for the final version 1.0, we are targeting 2025 October. Unlike LVGL, which is free and open source, this UI editor is a proprietary software which can be used by purchasing a subscription. We will tell more information about the licensing model and the pricing in the near future. Okay, so instead of just talking about it, let's try it out in action. So this is how the editor looks like by default. And the first thing that we need to do is generate code. For now, it just converted these XML files to C and header files. The next thing that we need to do is compiling the project. It will compile both LVGL and these few C files that we already have here. It also means that if you create new widgets and you add custom C code, custom event handling or custom APIs, then those C code will be recompiled and will be part of the editor. So you can use your custom widgets and run your C code as well. Let's create our first component. I will call it gauge. And here we can start typing our XML tags. I want to create a component, so all I need to do is adding an opening bracket, and from the list I can select component. I like to implement the view first, so how this component looks like. As I add it, what I have so far is immediately previewed here. I want to start this widget not based on this rectangle, this basic LVGL widget, but based on an arc. So I can set what it extends. It extends an LV arc, so it will work based on that. It looks a little bit weird that this knob is cropped here. I can create a preview. On this preview, I can describe any kind of style properties, like I will add some padding to my preview. Now there is a distance from the edge, so this knob is not clipped. I can also change the background color. Oh, it's not too good, but fortunately I have a color picker to pick a better color. I will also create a label and align this label to the center. Great. To add the text, I can just type the text property and add something here. If I want to make it a little smaller, I can just set the width to, let's say, 100 and also set the height to 100. Great, I just created a component. If I create a new screen, let's say main screen .xml. Here I need to start with a screen tag, also describe the view here. I set the width to 100% by default, just like the height. And here I can create any kind of LVGL widgets or custom components as well. I can create an LV label here as well. Call it main screen. And also use my new component. To make it positioned automatically, I can just set a layout to place them below each other. Okay, it's nice and it's actually working. If I click this inspector tool, then I can click on these widgets. I can change their size. Now I can change the position because there is a layout, but if I remove the layout, I can also change the position. The layout is stronger than the manually set position. It also visualizes the padding here, and for the arc it also shows this click area with the dashed line. Alright, it's not that useful right now because, okay, I have created an arc, but I can't really do anything with its value. In order to create an interface for your UI, where the application and the UI can be connected, you can create subjects. It can be created in the global.xml file, in the subjects tag. Let's say I create an integer subject right now. The name will be temp1, meaning temperature 1, and the initial value is 35. So a subject can be imagined as a global data where both the application and the UI can write and store its data. In case of the temperature, it means if you measure the current temperature in a given room, you can just set it in temperature1 subject, and if any parties like label, arc, slider, any kind of widgets are interested in this, they can subscribe and their value will be updated automatically. I go back to my main screen and connect this gauge to this new subject. It can be done by using the bind value property. So now it's connected. As you could see, the value jumped immediately to the default value. Now you can't really see what's happening. However, if I create a similar gauge, both are connected to this temperature1 subject. If I change one, the other should change as well. So it's really some global data where the temperature is stored. Now I will show you how to update this label as well. Let's go back to the gauge and we will create an API for our component. In this API we will have only a single property. Its name will be just subject, let's say, and the type is also subject. So the question is what we do with this property if it's passed to this component. From one hand, we need to forward it to the arc and use the same bind value property. We can reference the API properties with a $sign. So like this. And we need to also connect it to the labels text. For this, you can use bind text like this. For the property, you can also define a default value. So if it's not set, like here it's not set yet, you will see how it looks. And now these are connected. If I go back to my screen, now instead of using this bind value, I will have an option to set the subject to temp1. I will do it here as well. So now everything is connected. If I change, for example, the range of the second, the values are still connected, but the range is also applied. If you would like to add an event as well, you can just add it as a child. So it's a callback related event, meaning if a trigger happens, like the arc is clicked, a callback will be called, let's say, my callback. Now if you export code and open the generated C file of the screen, you will see how it looks. So we have just a main screen create function which returns an LVGL widget. We have no style, so the style init section is empty so far. We create a screen here, apply the layouts, create a label for the main screen. We create the first gauge and we have the second gauge here as well. And we can also see an event added to the first gauge where my callback is called, and event clicked is the trigger which will activate this callback. The last thing that I like to show you in this presentation is how you can use styles. Let's go back to the gauge and create a styles section. In here I can create a style, name it like main style, and maybe I just changed the background color here. Now I need to add this to the arc. And nothing happened. Oh, it's because we also need to change the background opacity as it's transparent by default. Okay, now I can see it. Let's set a radius as well. And a little bit of padding. If you don't want to set these values like manually to try them out, for example, a little larger radius, or even larger, it's like a slow process. You can just press Ctrl and with the up and down arrows, you can change these values in a quicker way. It works here as well. If you also press Shift, it updates faster. I can also change the arc color. Okay, it's not that nice, but maybe I can make it a little better. Like this. If I want to set the color of the indicator part, then I can create a new style. Name it indicator. And set the arc color here as well. Assign the style to the widget, but now target the indicator, and now it's red. In the same way I could change the color of this knob as well, and other parameters just like the arc width, for example. By adding a little padding here as well. I can align it to the center. And with another style, I can hide the knob. Just setting the opacity to 0. Like this. And that's what I could show you in these few minutes about LVGL UI editor. I couldn't show you the Figma plugin, the online preview and font and image handling, but now you can have a basic idea about what we are working on and how this tool looks like. If you would like to try it out, you can just go to LVGL/LVGL editor, and here we have a readme about basic description, the latest video about how you can use the editor, and also on the releases page you can always download the latest release. Let me tell you what we are working on right now. So as I mentioned, we will release the UI editor in 2025 October, but besides that we are also working on a 3D renderer for OpenGL. For example, this truck was already rendered with that. Obviously for this you need a GPU which supports OpenGL as well. Of course, we also keep supporting our chip vendor partners and continue improving LVGL as well. So that's all for now. Thank you for your attention. I'm looking forward to hear your questions. Shia.